Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have a special guest whose name is Mick McDaniel, and we're going to talk about the factory that Mick is operating in America. It's a solar manufacturing factory that I have actually visited. It's in Indianapolis, which is in Indiana. That makes it kind of simple because those names sound almost the same, and it makes us know that there's race cars and fast solar cells and solar modules, I guess, right? Is that what's happening, Mick?
That's right, right here in the heartland. They
Yeah.
call it the crossroads of America.
That's what Indiana and Indianapolis is known for, I guess.
It is, we've got three major interstates that crisscross right here in Indianapolis, I-70, I-65, and I-74, and they all come right through the center of town.
All right. Okay, cool. So you can just pretty much get to anywhere you want. You could come on over here to where I am or where anything is. And so pretty cool. I went and saw your factory, and it's the Bila Solar Factory, and it's brand new, I guess. And you were just starting to push out a couple of modules when I was over there doing a class that was really cool. It was Jefferson Electric and a couple of other solar companies. There's a guy, Joel Walsman, that's had me come out there a number of times to teach some of these NABCEP prep classes. And it was pretty cool too. He got his competitors to come in and go in on the class with them. So it saved everybody money. And so that was pretty good. And I just like to see how people can work together instead of competing against each other. So what's up with the solar factory? How's it going today?
You bet. In fact, a quick comment, Sean. I don't know Joel as well as you do, but everybody speaks so highly about Joel and the work he does. And he's promoted solar for a long time, kind of an institution here in Indianapolis. So it was great that he had you out and did that training a couple months ago.
Yeah, he's just a super positive guy, very good entrepreneur. He also has a really cool YouTube channel I'll put in the show notes where he's
That's a
got,
good, I
yeah.
hear he's on TikTok too, which is
Oh,
way over my head, but yeah, that's pretty cool.
yeah, and he produces his videos really good. And it's like he does electrician stuff, talking about where the meters and all that kind of stuff. And he's really good at it. So I better watch out. He's going to come for my business. Just kidding. And it was a pretty neat class too. It was inside of this coffee shop that he owned. I think he just sold it, but it's just this really nice coffee shop. And upstairs, he had a classroom and all kinds of stuff where they do weddings and things like that. Then another thing about Indianapolis solar installation companies, one company that wasn't there at the class that I did was at Intersolar. It was at the Solar Games, and they won the Solar Games. So shout out to them for winning the solar games. It was like solar installation competition. So
Nice.
pretty good. And so I imagine all of these companies are going to start using Bila solar modules because they're made at home right there. And there's also been some announcements made too about teaming up with ES Foundry. Is that for the
Right.
cells? Okay.
That's right. That's right. Yeah. So we got going about 2 years ago. We started this effort. There were just two of us at the time, my colleague Wei Tai Kwok and myself.
Yeah,
And
he's a friend of mine too, and he lives right close to where I do. And he was like the mayor of Lafayette, California, which is pretty cool.
you're right. Yeah, he was the assistant mayor. Yeah, you've known Wei Tai a long time. So he and I were former colleagues back in about 2010 at SunTech,
Great.
where we worked for Dr. Zhengrong Shi.
Yep, I know
And
him too. Yep.
yep, and Dr. Shi's been around solar.
He was on the cover of all the solar magazines for a while there. Yeah.
Yeah, I think the New York Times dubbed him the Sun King at one point way back when.
Yeah, and
But
he's still called Sun Man and
yeah,
and
exactly. So
yeah.
we are an offshoot of one of his companies. We're actually funded by Australian private capital, and we incorporated about a year and a half ago. We picked the site here in Indianapolis. We looked at about 30 different sites throughout Ohio and Indiana, finally settling in on the site you visited, which is the former Eli Lilly manufacturing facility here on the south side of town. And we spent about a year getting equipment in and remodeling. And then December of last year, we started turning some panels off the line. And, it's just been a wild ride ever since. So,
Uh-huh. Yeah, and there's
But
some interesting technology that you've been doing. And so originally the whole deal, I guess, was it was going to be flexible solar. And I know you're still doing it. And so it's like, what is it made out of, the flexible solar? Instead of
yeah,
me
you know,
saying the wrong thing.
oh, no problem. Well, it's an aerospace polymer, and that is on the front layer, which
Hmm.
replaces glass. So it's a glass-free panel.
Hmm.
It has this aerospace polymer on the front. And then instead of a traditional back sheet, it also has a polymer-based product on the back. So again, two kind of aerospace-related products on the front and back, no frame. So it's a frameless module, which is what gives it a little bit of that flexible ability. And it comes in at about, 20, maybe 25% the weight of a traditional solar panel.
So how much does it weigh then?
The standard product, which is a 520 series product, it's a 72 cell mono-PERC panel. So it's traditional crystalline silicon. It's funny, people see this product, and anyone who's been around the industry for a while, the first thing they say is, well, that thin film or that thin.
Oh,
And, I have to stop them in their tracks and say, no, this is not
uh,
thin film. It's a crystalline based product. It just happens to look like thin film since it doesn't have glass
doesn't.
or a
It looks
frame.
like solar cells to me.
Yeah, oh, I know,
Hmm.
but kind of the novice sees it without a
Uh-huh.
frame and they immediately think it's thin film. But yeah, so it's a 520 watt panel, 72 cell.
So it's not half cells.
They are half cut. Yep,
Oh, they're half
72
cut.
half cut.
Okay.
72 half cut,
So like 144 half cells, I guess.
144 half, and that comes in at 17 pounds.
17 pounds. Do you have the pounds per square foot right off the top of your head or?
I should. I used to have the kilograms per square meter.
Uh-huh.
Yeah, it's installed. It's under a pound a square foot. It's probably closer to a half a pound a square foot installed.
Yeah, so pretty light. And so that's really good for places where there's snow and all that kind of stuff. And I know one of the ways that you were looking at installing it, or it is being installed, is by gluing it down. Is it on a membrane roof?
Yeah, so we have a pretty unusual way to apply the product, and we have a partnership with Dow Chemical out of Michigan, and we're using one of their industrial glazing compounds. It's an adhesive, and they have traditionally used it in high rises to hold windows into window frames. So it's a tested and proven adhesive. And the best application, like the purest way to apply our lightweight panel, is on a metal trapezoidal roof. Or,
Okay.
you think of kind of like a parking structure at a multifamily building that has kind of that trapezoidal shaped metal. And we can use this adhesive and literally put the panels directly to the metal. You had mentioned membranes, and that's another great application for us. But we do like to put a thin rail underneath the panel on top of the membrane so that the panel's not flush mounted on the membrane. So again, there's a
Okay.
little bit of
So a little
a
space.
backing, yeah, a
Yeah.
little bit of a backing rail that we will mount
Yeah.
first. But otherwise, yeah, we use the adhesive for membranes in those metal roofs.
Oh, great, great. Okay. And so I'm trying to think of how to describe what a trapezoidal metal roof is. What is it, about every foot or so? It goes up and it's got a high spot and there's like angles as it goes up. It's not like corrugated where it's just like round where it goes up. It's like got a couple of angles to it. And
Yep.
that's sort of like a trapezoid, I guess, like some kind
Yeah,
of.
absolutely. And even corrugated is a really good application too.
Hmm.
I think of those old Quonset hut style buildings that are, some people call them barrel roofs, but those are also good applications for this adhesive and the lightweight panel.
And then the other thing that I saw too is you had some rails for it, and I believe they were fiberglass or something like fiberglass.
Exactly right. Yeah. So we offer that same lightweight product that weighs 17 pounds, but we've developed a fiberglass reinforced material that we have extruded and then mounted to the back of the panel. So it really functions more like a back rail. And we can use a traditional clamp and mount that into a solar system for the most part. But that adds a little bit of weight to it with that backing rail on it. It's about
Mhm.
24 pounds. So still pretty light.
Yeah, compared
Um,
to like some big heavy 500 or 600 watt module with big old aluminum frames. And then the other thing too is if you don't have the frames, you don't have to worry about the moisture buildup, as the little ridge of the frame there. So it just can run off. So that's pretty good too.
Yeah, in solar, we should come up with a name for that because for years I've been trying to describe that to people and anybody in the industry. When you talk about that soiling that happens at the bottom up
Yeah.
against the frame, we all know what we're talking about, but we've never come up with a great name for that.
Let's not call it a dam frame, but a frame dam. How's that?
I like it. I like it. We
The,
could maybe
the,
get Chevy Chase involved in that.
okay. Yeah. He might fall down though. So there's all of this technology. It's like super lightweight, so you don't have to put extra weight up on the roof. And are you working with any ballasted systems for this technology?
Not really. We have used it and tested it with some of the existing ballast systems, but it kind of goes against conventional wisdom in a ballast system,
Yeah,
right? I
because
mean, with a
it's
ballast, yeah,
lightweight. Yeah.
exactly.
You're making something heavyweight. Yeah.
Right.
So that kind of makes sense. Yeah.
Right, yeah.
And one of the things that I thought of when I first saw this product, I think it was like actually years ago, I was talking to Dr. Shi while he was developing it at the SNEC conference, and I was thinking rapid shutdown because there's a way to comply with rapid shutdown for PV systems on buildings where if you don't have exposed metal parts and exposed wiring methods and, like metal frames and rails, then you're a lot less likely to get shocked, or a firefighter's a lot less likely to get shocked. Sort of like the bird on a wire thing. Even if there is a connection inside the silver and the cells, if there's a fire going on, there's nothing to complete the circuit like a frame or a rail. And that was what we called the BIPV method in the 2020 NEC. And they kind of got rid of that in the 2023 NEC as far as being a method in 690.12, but then there's UL 3741, and there's new types of systems that people are calling UL 3741 that have like metal frames and things like that, which is a little bit controversial, especially amongst the people that originally wrote the UL 3741 standard, and they say that that might change. And so I think that your system is a good system, or it could be made into a good UL 3741 system for rapid shutdown that wouldn't be controversial.
Yeah, I'm glad you bring that up. We, being a new company, a startup company, and sometimes limited resources, that is on our radar. We are very interested in beginning an effort here in 2025 to look into 3741. A quick shout out to my product team, but we've got a great guy leading our product effort. His name is Blair Reynolds. And
oh yeah, I know Blair. Yep.
You
That's
know
my middle
Blair
name too, is Blair. So yeah.
Okay. So yeah, we're going to go down the path of exploring this product in a 3741
I'm sure
certification.
Blair will get you there. Yep.
Yeah, and you're right. I mean, without a metal frame, the fact that we don't have to ground this frameless panel, a lot of those elements seem to play very nicely with what 3741 was written to accomplish.
Yep. And yeah, 3741 is a standard for rapid shutdown that you would use as one method for rapid shutdown. So another way to comply with rapid shutdown is just module level electronics, pretty much, to keep that voltage down after shutdown is initiated for rapid shutdown of PV systems on buildings. So that's all kind of neat stuff. It's flexible. You gave me like some pieces of it, or like sample modules, and I have them in my suitcase. That's this world's smallest grid-tied battery backup PV system that I take to a lot of my trainings. It's 70 pounds. I can get it on the airline without paying anything extra. So thanks for adding to that. I can go out there and, grid tie to different places. I've been grid tying to different conference centers and stuff lately. And so the other announcement, though, was also interesting to me about ES Foundry. So they're supplying cells for you, and you're going to also be making regular old traditional super boring PV modules that everybody makes with the aluminum frames and all that kind of stuff. So did you have to retool the factory? I guess you must have known about it a long time before it was not a secret, or, probably when you're doing negotiations and stuff like that.
Yeah, that's a great question. And how early did we know about it? I think people within the company would argue when we knew we were going to do that. But,
Uh-huh.
it's a bit of the solar coaster and it changes
Mhm.
every 6 months. I've always said in this industry, take any company and in 6 months, they're going to be doing something different, or at least slightly different. And I think in our case, that's exactly what we did. As the clarifications came out from IRS on domestic content, and we were out talking to clients, and they really started telling us how important domestic content would be to their projects. We thought it was just a natural kind of addition to what we're doing in Indianapolis to add the capability to do a traditional, as you say, kind of boring, 72 cell, 144 half cut. Mono PERC is what the cell technology is. And, it's not leading edge. It's not the most exciting thing, but the fact that we're using a US cell and we will be incorporating much more US supply chain and bill of materials into that product is going to make it a fun product for us.
Yeah, and that's one thing that I think a lot of people don't understand is they'll say, "Oh, this solar module is made in America," but maybe it was just the last little part of the process of assembling the module, not the cells and all that kind of stuff. Another thing that's in the news all the time is, all these tariffs. And if you kind of zoom out and look back at it from like multiple administrations, it even seems back like you go back long enough even to Obama, and it was like more globalization. And it seems like every step along the way, whoever's president, they're getting a little bit more or even a lot more focused towards made in America.
Mhm.
And so some of the things too is like with the Biden administration, there was the IRA and a lot of this, like you were saying, domestic content. That's like things that are made in America, like the cells and all that kind of stuff. Is any of that stuff going away? Like I know that there's talk of, oh, that was a Biden thing, let's get rid of it. But also it's a made in America thing, which it seems like the current administration is, way for made in America, like with all the tariffs and all that kind of stuff. So is that IRA stuff still in effect? And is it
You
looking
know,
like it's going to stay that way?
I figured, knowing I was going to talk to you today, that you were going to make me pull out my solar crystal ball.
uh
So I'll get it out now, and I'll tell you what
Well,
I
solar's
think
all
would.
about crystalline silicon.
That's exactly
You
right.
can make your own crystal balls. And if you don't want to talk about this stuff too, we could
Oh, no, no,
cut
not
it
at
out.
all.
Yeah.
Yeah, it changes so fast, right? I mean, I
Mhm.
often tell people, and I was with SunTech back in the 2010s, and I was with First Solar before that, and with Sacon before that. So, maybe haven't been around the business as long as you have, but been around it long enough to know that it just changes so fast. Again, companies have to be very nimble, be able to change kind of their businesses quickly. And I think we just don't know with these tariffs. I've described it as playing a game of whack-a-mole. The minute we kind of get our supply chain set up, we feel good about it. We've got the lowest cost bill of materials that we can get that goes into our product. And then it all changes. And now
Mhm.
we have to go find new supply chain and new materials. So we're going through that right now as we speak. There were tariffs announced a week ago, and then more tariffs announced yesterday. And you start to add these on top of the material you're buying for your panel. And, it's a tough game. It's tough for everybody right now. I hope with my crystal ball that it just settles down enough to
Mhm.
give us certainty to go make financial decisions, just like our customers, the developers and the owners want to be able to know what the return's going to be on their investment. The same for us as a manufacturer.
Yeah, the uncertainty could be tough. But I would think that making solar in America is a pretty good investment. Like if I had $1 billion, I'd give it to you right now because you're making solar in America. It's just like I think like progressively there's been all these different administrations that are just going further and further towards, made in America. And there's just kind of a lot of people out there too that want made in America, even if it costs a little bit more, because we do, like we treat our employees better and stuff like that. And so that's pretty cool that you guys are making it in America. And I think that just from my perspective, I think you're going to do great.
Well, thank you. No, I agree with that. I would say the most rewarding part of the last 2 years for me personally has been to be involved in the effort to bring solar to Indianapolis. I was born and raised in Indy. I'm a Hoosier, through and through, graduated from Indiana University and
Uh-huh.
went off to kind of chase my solar career in California and in New York. And now I'm back and we are bringing solar manufacturing to downtown Indianapolis. So I'm with you. The fun part of this story is telling people that we're creating jobs, and those are good paying, clean tech jobs, and careers are coming from all of this. So that really is the fun part of this effort, to go down the path of creating jobs and building products here in the Midwest.
Yeah, it's kind of cool that I know people that could install solar and literally carry it from the factory to the job
That's
because they're
right.
so close. And you have the lightweight stuff too. And the choice of Indiana versus somewhere else in the United States, maybe part of it had to do with you working for the company already or having a good connection with the company. And then being from Indiana, I'd imagine maybe that was part of the plan, you know?
Yeah, I'd like to think it was useful if it wasn't premeditated. At least it was
Mhm.
useful having me here in Indy. But yeah, I really think the Indiana Development Group was very supportive of our efforts. The location we found already had power, which is a big deal when you're trying to build anything right now that you don't have to order switchgear and transformers that take, 60 weeks or something like that. So we were fortunate to find a site with good power, enough space. The workforce here in central Indiana is fantastic. We have great universities for engineering. We have technical colleges close by for technical people. And then, like I said at the beginning, kind of being at the crossroads here and being able to deliver product to the East Coast and the West Coast out of a central location, all of that just came together, to your original point. I'd like to think I had something to do with it, but I'm
Uh-huh.
not sure.
Yeah, all those different reasons why, you pick a place centrally located. So I guess they could, ship it to either coast pretty easily. I guess, what do you put it on a truck or a train or something like that? Did they ever ship, like, go up to like Lake Michigan or something from there? Is that?
It's a pretty quick, I mean, it's
Mhm.
probably a 3 hour drive to get to Lake
Mhm.
Michigan. It's pretty quick.
You can truck stuff up there and get to the ocean from one of those Great Lakes. So that's pretty neat. So, what are some of the benefits to using your product and made in America and all that? Like, do you have the numbers or?
Yeah, on the glass product,
So when you say the glass product, that's not the flexible one. You don't,
right,
it's hard to make
right.
flexible glass. Yep.
That's right. It's interesting in the module business part of solar right now that there are almost no glass manufacturers. And maybe I'll back up a little bit and just to say that as module companies set up in the US, which much of it is a reflection of the IRA that was passed, 2.5 years ago, the benefits to support US manufacturing. But the supply chain has to follow us too, right? We can't just set up shop in Indianapolis and expect to have all the materials we need right here as well. So it is taking some time to develop that supply chain. And one of the most important things in a glass panel is the glass.
Mm.
And right now in the US, there's almost no supplier that can do the special thin, hardened glass that we use in a solar panel. So
Huh.
again, much of that is still being imported. But yeah, I think the special characteristics around the glass panel, we talked about it a little bit earlier, but it's this concept of bringing more domestic content to that platform. And you mentioned ES Foundry. We're very happy to have partnered with them. We announced a 300 megawatt deal over the next 2 years for cell supply, which is going to be fun. But we're also looking at things like the frame, EVA, and different elements in the panel, junction boxes, anything that we can move over to a US source for gets us out of that game of whack-a-mole that I
Mm.
talked about earlier. So that's really the goal with that glass platform, that glass panel, is to move that as quickly as we can and bring more domestic content into the product. And that only helps our developers out with the way the tax laws are set up. So that's kind of the focus on that product.
So making all these different components in the US seems like a great idea, but the problem is how fast can you set up shop?
Mhm.
So I'm sure with the factory that you're operating, it takes a while to get everything going and permits. And maybe one benefit of having a factory in Indiana versus California is you can build the factory faster, perhaps. I'm not sure, but I've heard rumors about things like that. And that would be a super benefit of why people build things in China, because they do stuff super, super fast. And so was it frustrating making a factory? Do you got some pointers for these people that make factory building rules, how you probably could do it faster and also keep it so it's not poisoning the environment and things like that?
That's a great question. It's probably a very long answer, but I will tell you the axiom that I used going through a year and a half of building a factory is everything is pretty much 2 steps forward, 1 step backward. You make progress towards your certifications, and then something comes up that was unexpected and you have to kind of reroute a little bit. But yeah, I think having a good construction partner is key to being successful. Having a good engineer on board, and we were very fortunate with local engineering and local construction partners. They really helped us stay within budget and kind of optimize the existing building we were in. We were not a greenfield, so we were taking a 60-year-old building and going in and changing it around, and that's kind of a different animal together. So yeah, I would think picking those partners is maybe the most important thing you can do. I mentioned the power side of the building. Right now, electrical infrastructure has pretty long delays. And again, we were fortunate with this location that we had a double tie switchboard already set up with plenty of power in it, so we didn't have to order any switchgear or transformers. Some of those things you just have to look at going in. And then the other piece on the equipment side, most of this equipment, in fact, I'll back up a little bit. It made me think of another topic. I was involved in building a factory about 12 years ago with a former company, and we did that in Goodyear, Arizona. At the time, about 90% of our equipment came from Germany, with maybe a handful of pieces of equipment coming from China. Well, fast forward 12 years and the industry has changed, and Germany is no longer the center of PV technology. In fact, China is the center for PV technology now. So what that means is in our current factory, 90% of the equipment came from China, with about 10% of the equipment coming from Germany. So there are all sorts of challenges right now in getting equipment out of China. And then you add to that the new tariffs that just were announced, which go on top of that equipment. So as we talk about expansion and as other companies talk about expanding and building out, we all now have a new cost we have to deal with on top of the equipment. So, there are little hurdles like that, but definitely PV and PV technology for the most part is coming out of China. And, getting the workers that understand the equipment, getting the visas so they can come over to help you set it up, getting the equipment to meet UL certifications, and then getting it over here. All of those things are challenges right now in our industry.
Maybe we could just come up with some kind of 3D printer that makes the equipment that makes the modules. I guess you call it a fab, I think. There's a big old assembly line. Yep.
That's right. Wasn't Applied Materials doing that 20 years ago? You could just plop down an order and they'd send you a fab in a box and you'd set it up and you were making PV panels.
Yeah. Yeah. And it's kind of crazy too how in the US, we invented the technology, and then it goes from the US to Germany to China and hopefully back to the US.
That's right. That's exactly right.
Are they making any of this equipment that assembles modules in the US? Is there any plans for that?
That's a great question. And I think it's something we'll be looking into this year because we do have plans to expand, which we'll probably talk about here. I don't have the answer sitting here. I mean, there used to be, right? There were strong manufacturers in the Northeast that built a lot of this specialized cell equipment. But yeah, right now on the assembly side, on the module assembly side, I'm telling you, it is all coming out of China.
Mm-hmm. Okay. Yeah. Well, I think all the listeners here or tomorrow are going to go set up factories that build the equipment that go in factories to make PV modules. Maybe we can set up factories that build the equipment that set up factories that build the equipment that make solar modules, something like that. We could just mass produce all of this stuff. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. One of the things too about like getting things done and permitting and all that that I just had a thought about was with residential solar even, there's a whole lot of costs that go into permitting. And so it's like different for every place, and the PV people in the US are paying 3 times as much as the world average for residential solar, like upwards of, over $3 a watt compared to $1 a watt, something like that, probably average for the world for residential solar. And we have different organizations that are coming up with the expedited permit process, or we've been working on that for a long time. And there's like Solar App is, for instance, Sol Smart, Solar ABCs, all that, these different ways to do that. Maybe we should add to it, instead of expedited permit process for residential solar, it could be an expedited permit process for making solar manufacturing factories. And then all you have to do is go on, fill out a 1-page form on the internet and start building your factory.
Yeah, I like it. I like it. I'll sign up. You get it together and you'll have your first customer.
Yeah, because it seems like we need to be able to speed up things. And I guess part of the problem, I think, comes from just the way that America was founded. It was 13 separate colonies. And so everybody wanted to have their independent rights and things like that. And then what it's ended up as is every building department or even every inspector has their own way of interpreting things and their own way of, this is the best way. And so we can't harmonize. And then we have to learn how to do things different ways in every different place. And it just gets tied up in bureaucracy. It creates a really big bureaucracy that probably isn't necessary. So.
Yeah, and Sean, you probably see that more than we do on the manufacturing side, but we felt like coming out of COVID, we started this effort 2.5 years ago. And I think kind of the local jurisdictions were still trying to staff back up and kind of find their footing after COVID just shut everything down for so long. And we probably ran into some things that took longer than they should have in a traditional building permit situation. But, I kind of wonder in solar if that has gotten a little bit better, over the last year or so as well. I don't know. But yeah, the building permitting stuff probably wasn't as smooth as it could have been. But I do think it was kind of our society getting back to normal after the COVID years.
Yeah, it's just different in every place. And it's not just solar, it would be for installing air conditioners or whatever, but especially solar, because a lot of times what solar is, you're just sticking something on the building. You're not like rebuilding the building. And it should be a lot easier, and just different places have their own different ways of doing things. Like, this is how we ground here in Chicago, or we bond the neutral to the ground at the meter can because we know better than everybody, or because the Chicago fire in 1878, that's why we do it that way, before they invented electricity. They were just preparing for that electricity. And then you hear about like all the bogging down of permits for the high-speed rail in California, just like kind of crazy, just going on and on forever, because they have to go through different cities. And everybody's like, well, I don't want them tearing up my town, and we want to put the train station here. Everybody wants their little piece. But I guess too, when you're going into a place, like I imagine when you're going to go build a big old factory that's going to create, thousands and thousands of jobs, is you talk to the people running the state and running the city and the county, and you say, do you want us to come here? You're going to make it easy for us, right?
Oh, absolutely. In fact, I talked a little bit about 12 years ago when my company did a facility. I don't have the numbers right in front of me, but just to give you an order of magnitude, that was about 100 megawatt facility. I think we had about 150,000 square feet. And I think the ultimate plan was about 150 people. Fast forward to today, and we've got a facility that's about 157,000 square feet. It could hold up to about a gigawatt. We'd have, probably 200 to 240 people, so we'd have a few more bodies in there. But when you compare the efficiency of what we do as a module company today to what we were doing 12 years ago, robots and machines have completely replaced people in these
Mm-hmm.
processes. I mean, we used to hand weld, hand solder,
I remember that. Yeah.
modules.
Hmm. I remember seeing
And
that happen in the Suntech factory.
exactly.
Yeah.
Yeah, that one Suntech building used to have 10,000 people that cycled through that building. So yeah, what we do today, with manpower is a fraction of what we were doing 12 years ago. So as I listened to your earlier comment, the footprint for a module co is pretty light, in terms of power is probably the most important thing we need, but we have very little exhaust, almost no water treatment, so we can go into an older building or a neighborhood and really not impact what's around us much. A little bit different for the cell manufacturing folks. That's an industrial process that requires wastewater and other things. But on the Module Co side, again, pretty simple. We've got people minding robots as the
Uh-huh.
machines do what they need to do.
So that would be a pretty good career, is to be a robot boss, a boss of robots.
Yeah, that's right.
And then you can also discriminate against robots and swear at them and not get in trouble too. So,
Yeah, I hate to go there, but I wonder if robots have their own DEI and different treatment, but maybe not.
yeah, sometimes I get afraid when I'm doing chat GPT and AI is if I'm rude to it, if it's going to, 20 years later, it's going to get back at me. Like, if I don't say please.
Well, I won't go down the sports analogy here, but I do know my son spent a lot of time on Chat GPT picking his NCAA picks, and it did him absolutely no good at all. Because
Okay.
really, all you had to do was pick the number one seeds and you were fine. So I'm not sure Chat GPT is going to get you everywhere.
Yeah, not at least today. Yeah. So when you say like a gigawatt, when you're talking about your factory, that would mean if you were going 24/7, 365, how much PV you could put out, like how many modules you could assemble. And a lot of times companies won't be working 24/7, 365. So is that correct? Is that how it is? Yeah.
Spot on. Yeah. And,
Hmm.
to give a little more color, yes, that's operating full time. And I think full time in kind of our module factory world is 4 shifts. So if you're running 4 shifts, you're going to get that annual throughput. When we started with kind of a half a shift as we got things going. Then we grew that up to 1 shift. By Q2 of this year, we should be moving to our second shift. 2 shifts on, a gigawatt's going to give you 500 megawatts over 12 months. So yeah, that math is kind of very linear when you're
Hmm.
starting to figure out
Yeah.
throughput.
And is it like unheard of to go full speed for a whole year, 24 hours, 365 days? Does anybody
I don't
work that hard?
Yeah, I don't think it's unheard of. And, I
Right.
think at times in our industry, that has definitely been the case. I think right now it's not the case. In fact, I'll talk a little more specifically now to what we have here in Indianapolis. We started out with a 150 megawatt line, and that's what we wanted to kind of turn on and practice on and get going on. And we're in the process right now here in April of adding more equipment. We will, by the end of this year, be at a 300 megawatt annual capacity on the line that we have. And then again, with a little bit of luck and some predictability in the market, next year we should grow that and maybe add another 500 megawatts to that. So our building has a footprint that we can put about a gigawatt into. We should be at 300 by the end of the year. And then we've got room to add another 5 or 600 next year.
How long does it take to make like one single module? Like for you, like let's say you already have the cells, I guess, and you put cells and glass and I guess like extruded aluminum that's going to be the rails and all that. You stick that in one side and out the other side comes a module.
Yeah, I think probably 6 hours would be, the number, and it can vary a little bit. I mean, there's some time in the curing chamber,
Hmm.
and that can depend on kind of temperatures and humidity. But to move through the line, it's probably an hour or so for the panel. It's not real long. The longest time spent is going through the laminator. It moves very slowly as it moves through the lamination process. And then when it gets over to curing, it spends 3.5, 4 hours in curing. But yeah, so, kind of half a day, maybe 6 hours,
Mhm.
something like that.
So I was thinking about like half cells. You're going to have twice as much soldering going on because you're going to have like twice as many half cells as there are whole cells in a PV module. And I guess the reason that half cells are feasible and economical is because you have the robots doing the soldering.
Absolutely.
And without robots, then it would not make sense at all.
Yeah, I
Yeah.
think a lot of the things we do nowadays would be very difficult to do if they were manual.
Yeah, I knew a guy, Mark Morose, and he was hand soldering solar cells for space, and call him the world's first solar installer, and have him on a podcast talking about that kind of stuff. But come a long way.
Absolutely.
One thing that I was thinking of too is like if you could do a gigawatt in a year, if you divide a gigawatt, like a billion watts, by the number of hours in a year, then you could say how many whatever kilowatts or megawatts per hour you would have.
That's right.
So you could call it a kilowatt hour, maybe. I don't know.
Kilowatt production hour.
Yeah. And I guess too, with manufacturing anything like cars or whatever, if you can't find one component, you have to stop. Is that a problem that you experience, or are you just the supply chain's good enough where you're not going to have that problem?
Yeah, I think we try to buffer the supply chain a little bit. We'll try to have multiple suppliers, which as we grow is going to be more and more important. But really, I think just on our material inventory on the front end is how we would try to solve that problem. I think the bigger issue we've seen already is you have this very fancy automated equipment, and then, a vacuum pump goes down, and it doesn't just go down, but like the casing cracks, and, even your best engineer can't repair a cracked casing on a pump. So
Mm-hmm.
I think just having the right spares around for your manufacturing equipment is a real trick, but extremely
Mm-hmm.
important because, some of this, like the laminator is a single piece of equipment. It's about 110 feet long. It's a big piece of equipment. It's like my colleague describes it as a large pizza oven. The pizzas go in on one end and they come out on the back end, and you have to keep that equipment up and running all the time.
So when you're buying a laminator, it's 110 feet long, so they have to put something on a ship, I guess, and
Well,
it's that
ours
long.
came in 6 pieces. So they were stacked when we put it together. They were two high. So three across the bottom, three across the top, with two more on the front end. I think each one of those pieces was like 22 tons. And so you start to add up the weight and it's unbelievable. But yeah, it came in pieces like a Lego kit, and we got to put it together.
Great. Okay. Yeah, there's so much that goes into manufacturing and making factories and all that kind of stuff. But I think it's really important. I think it's really cool that everybody's doing it in the US. So, any other things there, any secrets you wanted to tell me or anything? Like
Any secrets? Well, I hope my crystal ball is working. No, the only secret I have is, this is a great industry. I've been real fortunate over the years. I met some neat people like you and my colleague Wei Tai, and it's a fun industry with a lot of fascinating people. Your listeners out there, if anyone's looking at a career path, I think this is only going to become more important as our energy needs grow and we try to support the data center growth and the AI growth we're seeing in the US. So I think the jobs that you're doing and I'm doing and others in our industry are extremely important. And, I hope our young folks coming out of schools feel that way and want to get involved.
great, great. Okay. Anything else you want to talk about?
I'd love to hear a little bit of your history. Like, what was your first solar moment? I mean, when did you know that you were going to be working in solar?
Gosh, that's a good question. I know like in the 90s, we had an off-grid system up in the mountains that we would play with and didn't know what we were doing. And I'd be reading Home Power magazine and, like thinking that it was really cool. And my grandfather was one of the world's top experts in hydroelectric turbines. And
Oh,
so,
interesting.
doing engineering and traveling around the world and figuring out how to work with desalination plants and spin things for electricity. And I remember when I was a little kid walking around in the woods trying to figure out where to put a micro hydro station and stuff like that. But yeah, the 90s, we were just, playing around with this stuff. And also in the 90s, a guy, Paul Finn, who I met at Jerry Brown's house before he was mayor of Oakland, and he was just a community organizer. And so I met my friend Paul, and he was a philosopher. And instead of writing philosophy books, he was like, I'm going to write a law. And he wrote a law called Community Choice Aggregation, CCA. And we were just kind of like a couple of radical dudes, and I guess we were in our 30s at the time. And we would go make signs and protest. And then he had a law that passed in different states. And now a good portion of the people in the United States get their electricity through the CCA law, which is pretty cool. I know that Waitai gets his through the CCA law, but my city is a little bit backwards, and we're surrounded by every other city that does, and our city council needs to be replaced. But it's not in every state that has the CCA, and a lot of people that get their electricity through a CCA don't know about it. And so that kind of stuff was in the 90s, but I got into solar full time in 2008, and it just kind of took off. I didn't know what was going to happen. I got a full-time job. Somebody was teaching a class, and after getting the full-time job, I talked to somebody that was teaching a class, and they didn't know what they were doing. And I had already taken the NABCEP exam, and they're like, maybe you could teach it. And then I taught this class, a few hours a week, and they liked it. And then pretty soon I got a LinkedIn response. And so by the end of 2008, I was full-time teaching. Although my first job wasn't teaching, I was working with a guy that's really successful in the solar company, Stuart Wentworth, and we were the solar division at Fidelity Roof Company. And he invented quick mount. It was a flashing that everybody copied. And then after that, I've been teaching full time since 2008. It's been quite an adventure, and I love it. So, yeah.
Nice. Well, I appreciate all you do. I know last time we were together, we brought up, Bill Brooks's name, and I think we brought up Ward Bauer. And my first kind of where I crossed paths with solar was in 2005. I went to work for a UPS company by the name of Satcon. And they realized very quickly that their UPS system wasn't very good, but they built these little things called solar inverters, and people in California wanted to buy them. So I took a flight out to California to try to figure out why people were buying these solar inverters. And we had a great salesperson, and you probably know Terry Sholin was in California, and I spent a week or so with Terry. And I went back to Boston and said, you know what? I think we can sell these solar inverters. People want to buy them. And that's kind of how I got started. But I remember Bill and Ward, and then as you came on the scene, and you guys have done a lot of great things for the industry. And you've kept a lot of us safe because you put knuckleheads like me without, engineering degrees, even though I've been around it, we can get into a lot of trouble if folks aren't educating and keeping us out of trouble.
Yeah. And Bill Brooks and Ward Bauer, a couple of my heroes. And I just had Bill help me interview Ward at the NABCEP conference.
Oh, nice. I'd like to listen to that.
Yeah, and so by the time this podcast is released, we will have released that one already. But right now we're just editing and all that kind of stuff. But yeah, Ward is like pretty much invented the modern solar industry, inverter. How were you working with Ward?
Well, again, we were nobody at Satcon when we started. We had like maybe a 50 kilowatt inverter, a 35 kilowatt inverter, maybe a 70 or 75 kilowatt inverter. These were central inverters. I mean, we hand built these out of our InverPower facility in Burlington, Ontario. And we didn't understand the US market. We didn't understand the code world in California. And I remember, I think, we hired Ward at one point to maybe come in and give us some advice. And we sort of did the same with Bill maybe once to try to get him in to understand how we could improve the features on the inverter and just meet the code. I had some great engineers up in Burlington, Ontario, but the Canadian guys didn't know US code and certainly didn't know California. So we had to come up to speed pretty quick on codes. And I think both of those guys helped us.
Great. Yeah. Ward pretty much invented the modern grid tie inverter in Sandia Labs, New Mexico in 1977. And I got to know him when I was on the NABCEP PV. Now it's called the PV Installation Professional. And they changed the name, and we just always called it the NABCEP PV Installer Certification. And so I was on the committee with Ward writing those exam questions, and he's still on that committee and I'm not. So,
Wow. If I remember right, he was like in Santa Fe or Albuquerque. Was he out in New Mexico?
yeah, Albuquerque still is. Yeah.
Albuquerque still is.
Yeah.
Okay. Gosh, that's a hard memory to
Uh-huh.
call on.
Yeah. Yeah. Super nice guy. Yeah.
Yeah, well, thank you for sharing your background. That's great.
Yeah, cool. Yeah, we'll put the podcast with Ward in the show notes here. And Bill's, one of my good friends. We own a sailboat together, and he's, in a lot of my classes and some of my videos. We do audio versions on the podcast. That's actually how the podcast started. I just started posting some audio versions of my classes on the internet, and I was like, hey, there's this podcast thing where I could post something, and then one thing led to another, and here we are.
Well, good for you. Yeah, I can't wait to dig in and listen to a couple of them. I have a new electric vehicle, which I'm thrilled about, but it's just so easy to put podcasts on from my iPhone now. So I guess a little technology has helped out this old guy figure that out.
Oh,
So,
great. Yeah, I just got an old electric vehicle, the original 2011 Nissan Leaf with a
ooh,
worn out battery that still has 30 miles of range, and that's all you need for most of your drives.
I know.
And then with the Leaf technology, it's pretty much always been able to be bidirectional. So even though that battery is a lot less than the original 24 kilowatt hours, maybe it's half, I could still take that battery, and if with the right inverter charger, I could power my house.
Nice.
Yeah, that's the goal.
Well, another topic that's interesting to us, and we haven't spent much time on it because I've been a little busy with a factory, but some of the recent developments, I think it was Utah that announced they had a balcony solar code or law
Oh
that
yeah.
was being accepted because we think it could be kind of fun to look at this ultralight panel, put them on a balcony with a very
Hmm.
simple power electronic device that you can put into, your house and connect it. I know they're doing that in Germany.
Yeah.
Codes here seem very restrictive to try to
Yeah,
do
kind
that,
of the
but
problem with that is if you're just going to plug into a regular outlet, it's against the rules.
right.
It's against the code. You need to have like a dedicated outlet or dedicated circuit breaker where you're going to plug it in.
Got it.
You
Okay.
can't be sharing it on a power strip where people could just start adding things and add a
Hmm.
couple thousand of them to power strips and power strips. And you could then see how it'd be possible for there to be some kind of problem. But yeah, in Germany, it's pretty cool seeing all this, balcony solar stuff. And then that lightweight solar seems like a great idea for balcony solar because if they didn't tie it down right, it would have like 100 times less chance of seriously injuring somebody.
Right.
So,
Absolutely. Yeah. And again, with the material, there are lots of options for attachment, whether that's, well, yeah, there just seem to be a lot of different ways we could attach to balconies.
yeah, and I think too that kind of product too that's a little bit flexible would be good for putting on sailboats and all that kind of stuff.
Yep. We've had a couple of folks inquire on the boat side of things. We're pretty active right now on the vehicle and the off-grid trailer
Hmm.
activity.
Great.
It's a great product for that. But yeah, we've had a couple folks on marine applications as well.
One thing that's interesting to me is like flexible solar. So you've got a silicon crystal. That's like glass. Glass is
Mhm.
not very flexible, but I guess what is it? It's so thin that you can bend it to a certain degree.
Yeah, Dr. Shi described it to me like a snake skin, right? You got these half-cut cells all lined up next to each other, and if you bend it very gently, it wants to just bend in between the cells. The cells can probably bend a tiny bit, but the bend tends to happen in
Oh,
between the cells.
okay.
And they're small enough that you don't necessarily see that.
Hmm.
But, you bring up a good point. Handling is important. People do have to handle this in mind that it is a crystalline cell.
Yeah, I guess I know, like, even with regular modules, back in like the earlier days before 2010, we were doing these classes at this place called Solar Universe. And one of the things that we'd show everybody is like, this is tough. Look, we can walk on it. And we'd like walk right on the middle of it and jump, bounce up and down on it. And that was like, it wasn't my idea to do that. It was the guy that owned the company was saying like, this is part of the class. This is your job. You know, you got to show them, because they were installing these early micro inverters and they'd want to be able to replace them. And now I go like, well, man, we shouldn't have been doing that. But you know what? That company went out of business. They gave me those exact modules that we would pretty much bounce up and down on every month for years, like over 5 years. They're sitting up there on my mom's house producing power.
Wow.
So, you know, and it's like, I'm sure there's some micro cracks in there,
Yeah. Yeah.
but they're working, you know, they're making power.
Exactly.
They might work a little bit better if we weren't bouncing up on down on them. And I noticed that some people too, they was like, man, this big guy, he's going to break it. And I was like, well, he didn't break it. You know, it was like really bowing in the middle, you know? So I guess in a way, even glass is flexible.
Yeah, in fact, Blair did a video when he was with Solar World. The product management team took one of their panels and drove a Jeep up on top of it. And you know, you see this big Jeep drive up and drive over a solar panel, and you're like, how does that happen?
Uh-huh.
And sure enough, and then the Jeep drives off, and you know, the glass isn't broken. And I don't know about the cell damage, but
Uh-huh. That'd
but
be
yeah,
interesting if it was plugged in and working while they did that.
that's a good point. That'd be a great demonstration.
See how many watts it lost. Who knows? Maybe they gained some, you know.
Yeah.
They put
Yeah, that's
energy
right.
into the system, you know, thermodynamics.
Yeah, the solar charging pavement thing that we're talking about. Yeah.
Oh yeah, that one that was like solar freaking roadways.
Yeah,
All the people that weren't in the industry thought it was so cool, and the people that were in the industry are like, "Give me a break!" Another one of these things, you know.
I know. There's always something out there.
Yeah, there's these things that catch the attention of the bystanders, the people that aren't in the industry, like solar that you can drive on, building integrated PV, taking over the industry, like instead of being a niche market. What are some other things like these little solar flower trackers? You know, they're really neat, but they're just not too normal. Concentrated solar where PV, where they're focusing light with a tracker and all that kind of stuff. Some of these
Yeah,
things are
one of
neat.
my early years in the industry, a colleague of mine, Mark Hensley, knew the gentleman at Arizona State that ran their test facility down in Tempe. And I don't know if you ever had the pleasure to go to that facility. They had like one of everything that didn't work very well in
Oh, great.
solar. And they had these bidirectional trackers and they were concentrating solar. So as a concentrating panel, I know what I'm thinking of. It was one of those Stirling generators.
Oh,
There
yeah,
we
for
go.
steam or
Now,
something. Hmm.
yeah. And so the thing actually had pneumatic valves operating it. And when you would walk over next to it, as it would relocate to aim at the sun, all you heard were the pneumatic actuators going off, going, and it was just rotating very slowly to follow the sun. I'm like, how does any of this stuff pencil out?
Uh-huh.
But yeah, they had some great contraptions at that old ASU test facility.
You probably remember that company, Hanergy.
Yeah, yeah.
And so it was like this company that was on the Chinese stock market, and everybody in China was buying it, and the stock price was just zooming and going up and up, and people were making millions or billions of dollars, something like that. And then one day it started selling and they put a brakes on it and they wouldn't let anybody sell any more of it. And I think that was the end of it. Like, I don't know if it still exists or not, but I remember doing a class in Shanghai. I think it was right in the middle of Shanghai, like near Nanjing Road, like the main part of Shanghai. And me and my friend Nick, we were walking around after class and we saw like a Ferrari dealer or something like that. And right next to it, looking almost like an Apple store, was the Hanergy store. And we walked in it and we're like, you know, this looks like an example of failed projects, you know, in the solar industry. Because they were having like, remember Unisolar, where it was like this amorphous silicon solar stickers. They had something like that. And the funniest one of all is they had a raincoat on the hood, had flexible solar on the hood of a raincoat. You know, they were doing some thin film stuff. And it's like, oh, that's really smart. You know, like I'm going to catch some sun while it's raining, you know.
That might be the classic. That might
Uh-huh.
be the classic. Yeah, I remember Unisolar, a funny application we had in about 2006 or 7. We did the Long Beach Convention Center, and it was through SIT, which was their roofing spin-off company. They actually used Velcro to hold
Yeah.
the panels onto the roof. And I mean, I was in the Long Beach Convention Center many years later for one of the SPIs. I forget which one it was. And that was still up on the roof. Velcro was still holding those unisolar panels on the roof over there.
Has anybody checked to see if it's still there? I was like,
No idea.
I've heard that like Velcro is one of those revolutionary inventions, so maybe you ought to revisit that for putting on some of that flexible solar you have.
We have looked at it. It's interesting for sure. I mean, what you find with any of kind of the stick and peel materials, even a really good 3M tape, they just tend to be too expensive. That's kind of the bottom line. It is its own mechanical invention that you're paying for to put on back of a panel. So, an adhesive has a little bit of cost to it, or, a racking system. But yeah, when you start introducing Velcro, you're paying for that on top of the panel as well.
Okay, so now I'm coming up with other ideas to fasten your solar. We got, besides Velcro, we have shoelaces, we have buttons, and we have zippers. And how about snaps?
Yeah, I think they could all work.
Just talk to the engineers. I'd figure out like how many pounds per square inch or pounds per zipper or fastener or whatever type you have. And then that way you could take it off nice and easy. Because as you know, solar's not waterproof. So when it rains, you got to put it inside.
That's right.
Most people don't know that. Yeah.
Don't leave it outside.
Great. All right. Well, very, very cool. All right. So anything else?
I don't think so. It's been a pleasure.
Yeah, maybe we could do it again after you've pumped out a gigawatt.
Yeah, let us go take 2 more steps forward and then fall backwards, and I'll come up with something else that's new and different for you.
Great. Yeah, we'll be interested in watching you. I'm always looking at the news, and when PV Magazine writes an article and things about like your ES Foundry connection and taking a tour there. So it's been great. Thanks, Mick.
Well, you're welcome, Sean. Thanks for having me, and look forward to seeing you here soon.
And thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more, to get yourself NABCEP certified, go to solarsean.com. And if you want to find out what Mick's up to, the website address for Bila Solar is what it must be, bilasolar.com. And that's a B-I-L-A. By the way, what does Bila stand for?
It was a 4-letter word that our marketing agency could trademark.
All right. So I can't name my kids Bila now?
Oh, have at it.
Okay. All right. All right. Thanks, everyone. Woo!